Hi, students. In this lecture, I am going to discuss problems based on rolling motion. Let us see. Right, see the question given. A solid sphere is set into motion on a rough horizontal surface with a linear speed v in the forward direction and an angular speed v by r in the anti-clockwise direction as shown in the figure. Find the linear speed of the sphere when it stops rotating and when slipping finally ceases at pure rolling starts. So this question is taken from H.C. Verma. Let us see how to start it. So this is known as reverse spin or back spin. So it is having velocity right side, but rotation is now anti-clockwise. Okay, this is known as back spin or reverse spin. So given solid sphere, omega value v by r when rotation stops and finally slipping stops. We have to find v value. Let's see how to solve it. So first note down given data. It is given solid sphere, velocity is v right side, omega is now anti-clockwise, and that is given as v by r. So we have to find velocity when rotation stops and when slipping stops, right? Now first focus the possibilities. Whenever having back spin or reverse spin, so we are having three possibilities. So possibility one, the body continues to move in the same direction. And next possibility, body stops and moves back. And the final possibility is it comes to rest finally. Let us see how to decide these three possibilities. So first, we are calculating at what time velocity becomes zero and omega becomes zero. So see once. First, observe here direction of friction for contact point. You can see velocity. Because of translation, velocity is right side for contact point. And because of rotation, it is again right side. See carefully. Because of rotation, it is anti-clockwise. Because of rotation, for this contact point, velocity right side. Because of translation, it is again right side. Means for contact point, velocity is right side. And we are knowing that friction always opposes relative motion. So relative to ground for contact point, velocity is right side. So friction will be left side. So friction is now left side. So since it is now slipping, friction is connected. Okay. So whenever body rolls without slipping, friction will be started. It is now slipping. Right. Now we can see frictional force opposite to velocity. So on this body, horizontally, only one force is acting. That is a frictional force. So this is now net force on the body. So acceleration will be acceleration of center of mass. That is equal to F K by M. Direction, it is left side. Okay. So acceleration is opposite to velocity. Then speed keep on decreases. Right. Next, now focus. Because of this friction, torque will be, if you take torque about center of mass, because of gravity, no torque. Because of normal reaction, no torque. It is only because of friction, and that is anti-clockwise. Sorry, that is clockwise. So because of friction, torque is now clockwise. But omega is anti-clockwise. Okay, that means omega starts decreasing. That means speed is decreasing, omega also decrease. Okay, so motion of the body depends on which becomes zero first. Okay, let us see. That means whether body continues to move in same direction, our body comes back, our body comes to rest permanently. They depend on whether velocity becomes zero first or omega becomes zero first. Okay, let us see first of all what is alpha value. Torque equal to Fk into R, that is equal to I into alpha. It is now given solid sphere. So about its own axis, I value 2 by 5 mr square into alpha. See what is alpha value. 1 r gets cancelled. Alpha equal to 5 Fk by 2 mr, that is alpha, which is a constant. Now we can write velocity as a function of time, omega as a function of time. So I'm writing here v equal to u plus ct. Let us see at what time velocity becomes zero. So v equal to, finally velocity is zero. V equal to u plus ct. U value how much? It is given v. Okay. Let us take here this as v naught. To avoid confusion here, let us take the values as v naught. And this also v naught. This is omega naught. Okay. This is omega naught. Right. So initial velocity v naught. Okay. Final velocity is 0. So v naught minus, why minus means if you take right as a positive, acceleration will be negative. It is left side. So v naught minus a value Fk by m into t. Or let us take it as t suffix v. This is a time taken for velocity to become zero. That means what is a tv? Means at what time velocity becomes zero. That is m v naught upon Fk. Okay. That is a time. At what time velocity becomes zero. Now focus at what time. At what time omega becomes zero. Now see carefully. Omega 2 equal to omega 1. Omega 2 equal to omega 1 plus alpha t. Omega 2 0. Omega 1, it is omega naught plus alpha t. So here, if we consider anti-clockwise as a positive, then omega naught will be positive. Alpha is now clockwise, it will be negative. Minus alpha. Alpha value here 5 Fk upon 2 mr into t. Let us take it as t suffix r, means when rotation stops. Okay. So tr is equal to so what we get in the place of omega v naught by r. R gets cancelled. Remaining is now 2mv0 2mv0 upon 5fk. Cross check once. I have taken the place of omega naught v naught by r. R gets cancelled. Remaining is 2mv naught upon 5fk. Okay. Right now, for the focus conditions, let's see first of all condition. If Tv less than Tr, see meaning of that. Time taken for velocity to become zero is less than that of rotation. Means velocity becomes zero before omega becomes zero. Then see what happens. So now, according to this condition, velocity becomes zero. So at one point of time, it has only rotation. There is no translation. Okay, according to this condition. So now you can focus for contact point velocity. Because of rotation for contact point velocity it will be right side. Okay, that means still friction will be left side. See carefully, here I have taken condition that velocity becomes zero before rotation becomes zero. Means before omega becomes zero. That means at one point of time, it has only rotation, right? And if you observe for contact point velocity, it is right side because of rotation. And friction always opposes relative motion. So friction is now left side. That means now what happens is because of this friction, speed starts increasing and direction of velocity will be left side. I hope you are getting this point. Since friction is left side, this is now net force. Net force is left side. So acceleration is left side. So velocity of center of mass will be left side. That means now body starts moving backward. Okay, it is like this, right? That means if velocity becomes zero before omega becomes zero, then body returns. Body returns. That means it moves back. See carefully. Only rotation because V zero. Get the point. At one point of time, it has only rotation according to this condition. So friction is now left side. Net force left side. ACM is left side. Therefore, VCM also left side. Its meaning is body moving backward. That means body returns. Therefore, condition is if velocity becomes zero before omega becomes zero, body returns. Next, if TV greater than TR, its meaning is omega becomes zero before velocity becomes zero. Omega becomes zero before velocity becomes zero. Now see carefully what happens. So at one point of time, it has only velocity, no rotation. That is now right side. Okay. So you can see for contact point velocity, it is still right side. Okay. For contact point velocity, still right side. So friction will be left side. Okay. That means now what happens is because of friction, now torque is anti-clockwise. That means body Body now starts rolling. It's already having velocity. Now body starts getting, or you can say gaining rotation. Means omega starts increasing. But now direction is clockwise. So up to this instant, rotation was, you can see here, rotation was anti-clockwise, right? Now what happens after this instant? After this instant, omega starts increasing clockwise. So at one point of time, rolling starts without slipping. That means in this case, body continues to move in the same direction. Continues to move in the same direction. Okay. And the last possibility. Last possibility, if both are becoming zero at same time, if both are becoming zero at same time, then what happens is for a contact point, there is no velocity. Therefore, there is no friction. That means body comes to rest permanently. Okay. So whenever question is given basing on reverse spin or back spin, we are having three possibilities, right? If velocity becomes zero before rotation becomes zero, then body returns. If velocity means if rotation becomes zero before velocity becomes zero, then body continues to move in the same direction. If both are becoming zero at same time, then body comes to rest permanently. These are now three possibilities. Okay. Now coming to in our problem, see at what time velocity becomes zero, m v naught by fk. At what time rotation becomes zero, 2m v naught by 5k. So from this we can say tr is less than tv. Its meaning is rotation becomes zero before velocity becomes zero. tv greater than tr, right? That means it is now this condition, right? That means body continues to move in the same direction. Okay. So now we have to find when rotation stops, what is velocity? When slipping stops, what is velocity? Right? So I hope you got clarity on this one. Whenever given back spin or reverse spin, we can cross check at what time velocity becomes zero, at what time rotation becomes zero. By comparing those two, we can decide whether a body returns or body continues in the same direction or comes to rest permanently. So now this is second case. First, rotation becomes zero. Okay. In fact, same thing we can decide by using conservation of angular momentum without using these things, and that we can try once. Now coming to this problem. Coming to this problem, first we have to calculate velocity. Let's see how to make calculation for velocity. When rotation stops, see what we can do. So at this time, rotation stops. So one thing we can substitute now this value in this case. Okay. So velocity when rotation stops, when omega equal to 0 is equal to initial value, it is v minus a value f k by m into t value. At this time, omega becomes 0. Okay. So I'm taking that here. 2m v naught. This is given v right here as per the question given v. So I have taken V 2mv upon 5fk. Fk cancels, m cancel. Remaining is now V minus 2V by 5. That is 3V by 5. This is velocity when omega becomes 0. So next we have to find velocity when slipping stops. That means when rolling starts without slipping. Okay. And we can see the same thing we can calculate directly by using conservation of angular momentum. That is what we have discussed in the last two questions, right? Let us see once here also. So here we got this value by taking first of all force equation, then torque equation, then we got alpha, then acceleration, then we found at what time omega becomes 0. Substituting that in this one, then we got this value. Now by using LCAM, law of conservation of angular momentum, directly in one single step, we can get this answer. Let us see how. Initially given V, and this is omega, which is equal to V by R. After some time, having only translation, no rotation. Okay. After some time, let us take this velocity as V dash. Okay. This is V dash. Having only translation, no rotation. Right. Now we want to use a conservation of angular momentum. Let us assume this line as x-axis. So now we can take about any point on x-axis. So this is what we have taken in previous problems. Because about any point on this line, net torque on the body is 0. So initially, if you take about a point somewhere here, you should be very careful with the direction part. Focus now direction part. R bar will be, this is R bar cross P bar, curl fingers of your right hand, keeping fingers on R bar towards P bar. So it will be now clockwise. So because of translation, angular momentum is a clockwise. And I am taking a sign convention. Let us take clockwise as a positive. Okay. Then because of translation, it is a positive. M, B, R. And you can see rotation is anti-clockwise. Rotation is anti-clockwise. So minus I value 2 by 5 m r square. Omega is given V by R. So why I have taken negative? Because it is anti-clockwise. This is equal to, at one point of time, omega becoming 0. Now having only translation. And again, R bar like this, P bar like this. Okay. Again, because of translation, it is a clockwise. So M V dash R. Now from, let's see what we can do. We can cancel M R square, right? Remaining V minus 2V by 5. That means V dash is equal to 3V by 5. Okay. 5 minus 2, 3. 3V by 5. So directly in one single step, right? Next one, we want to calculate when rolling starts. So rolling without slipping. Okay. Let us say this velocity. Take it as V double dash. And rotation will be clockwise because without slipping. Okay. Then what I can write here, omega value. Omega will be V double dash by R. So I'm writing once again, conservation of angular momentum for starting one and final one. For starting one, see what we got. V minus, this is MVR. This is 2 by 5 MVR. This is now 3 by 5 MVR. Okay. In left part, no change. Okay. Coming to right part, now body is rolling without slipping. So because of translation, it is again clockwise M V double dash R. Now rotation also clockwise. So plus psi omega 2 by 5 M R square omega. Omega is now V double dash by R. Root M R M R M R square, and here also R is there. Remaining is now 3 by 5 V is equal to 1 plus 2 by 5, 7 by 5 V double dash. Okay. That means V double dash is equal to 3V upon 7. Okay. Like this, we can solve by using conservation of angular momentum. Okay. So I hope you got a clarity. So especially basing on reverse spin or back spin. First, we have to focus which is becoming zero. Basing on that, we can decide whether the body moves in the same direction, our body returns, our body come to rest finally, right?